Right along the top of the page here, I know it's on your formula sheet, but just to jog our memory, I'd like to write out the impulse equation. Now remember, impulse is change in momentum, and our abbrev for change in is a triangle. One way to write impulse is to find impulse is to literally go final momentum minus initial momentum. I didn't blatantly put that on your formula sheet. I kind of did, because what does it say in the very top left on the front page? What's change in anything? Final minus initial. Oh, got a latecomer here interrupting my lesson. If you look at the impulse equation on your formula sheet, we also said you can find the impulse by going force times time. I think I put a delta in front of the time because there's a bunch of deltas in the equation. These are all change ins, but time is always a change in. So we get sloppy and we kind of stop putting the delta in front of it. And you can also find the impulse by going mass times change in velocity. I'm going from memory, but I think that's what it says. Oh, by the way, what's change in anything? You can also write this as mv final minus mv initial. Those are all contained in that. Nathan, it's important for me to say you can survive without the impulse equation. In other words, if I give you a question and you say, I'm not sure how to solve this using impulse, but I can solve it using F equals what? And VF equals VI plus AT. Go ahead. What the impulse equation will let me do is save about 3 lines, but it's not going to be doing something dramatically new. You're going to start to notice as we go through some examples, I'm going to say, we could do it this way, but look, this gets us there in 1 line or 2 lines. It's a nice shortcut. Okay. I called this multi-step momentum questions. This is just really me asking Ashton, what all can we do with the concept of change in momentum if momentum is mass times velocity, and if change in anything is final minus initial, and if it also happens to be force times time, because we did a little proof. A force of 8 newtons acts on an object for 10 seconds. I'm already thinking I'm probably going to be using the FT version of impulse, force and time. The mass of the object is 4 kilograms. Okay. Anderson, what's A want me to find? Keep reading. Change of momentum. I said magnitude because technically impulse should have both magnitude and direction. I didn't give you a direction here. So I'm being just nitpicky and saying all we're finding is the size. The first thing I would write is my abbrev for change in momentum. Which version am I going to use to find the impulse or change in momentum this time? How do you know? You're right. Okay, I see a force, I see a time. Yeah, I'm going to do that. In fact, it's going to be 8 times 10. You might even be able to do that in your head like me. Look at you. See that nice doing that in your head? What are the units for impulse? Well, it's change in momentum. You can write kilogram meters per second, and Maya, I'll give you full credit. But notice we went force times time. I would probably just out of habit write Newton times seconds because we did go force times time. But they're identical units. If you break them down, you'll find that also turns into kilogram meters per second when you do a little bit of canceling. I'll take either. I'll take either. Cody, what's B want me to find? What's the answer? Your hint is you already know the answer. All B is asking is, have you clued in that impulse and change in momentum are the same thing? I'm going to warn you right now on your momentum test, there is a multiple choice question where I phrase it very carefully to trick you, but all it's asking is, do you understand that impulse and change in momentum are the same thing? So what's the impulse? And again, you could say kilogram meters per second, or you could say Newton second. Okay. Ashton, what's C want me to find? How would I write change in? What's my abbrev for change in? Delta. What's my abbrev for velocity? What letter? Hey, what's the version of impulse that has a delta V in it? Yep. You're just M delta V, right? Yeah. That delta V is the change in velocity. Okay, how would I get the change in velocity by itself? How would I move the m over? What's the m doing to the change in velocity, Ashton? Adding, subtracting, multiplying, or dividing? We'll divide it. So are you telling me the change in velocity is going to be the impulse divided by the mass? Yes. Yet another equation. Don't write this down on your formula sheet. Please learn to derive these. Otherwise, your formula sheet's going to look like your pencil just puked all over the page, right? What was the impulse, Ashton? What was the mass? They gave it to me. I've scrolled down, but I'm sure I gave it to you. Oh, you might be able to do this in your head. 80 divided by 4? 80 divided by 4? What? I think you're right. 20. And this is velocity, change in velocity, so meters per second. Now, what does that mean? That doesn't mean that we started at 0 and ended up at 20. It just means that's what we changed by. If we started out going 4 meters per second and our change in velocity is 20, our final would be 24. If we started out going 50 meters per second, our final would be 70. All this is telling me, Holly, is my change in velocity. Okay. Hannah, what's D want me to find? What did I find in part C? What's change in anything? On your formula sheet, top left corner. Keep reading. Okay, so you ready? What does it want us to find? VI. What did we just find in part C? Change. You know what? I think I would write this. Change in velocity is V final minus V initial. What are they asking me to find, Hannah? Get the VI by itself. What's right in front of the VI that I don't like? I'm going to do the swappy dance here. What I'm going to do is I'm going to plus the VI to that side. I'm going to minus the delta V to that side. I think, Hannah, if I do that, I'll get VI equals VF, take away delta V. According to this question, Hannah, what's VF? Yep, minus. What's delta V? What do you get? What if I asked you to phrase that in terms of direction? Well, when you said 12, you decided that north was positive or negative. You decided, you could have said negative 12, by the way, and let south be positive. Would have been weird, but sure. So that negative is telling me not north. What's the opposite of north? So I would live with -8, or if you said 8 meters per second at south, I would take that too. If you said -8 south, I would take a half mark off, because I would argue that negative south is technically, I would argue it's north. So commit to one or the other. I'll do both in my answer keys. Probably most of you will just choose to go with a negative because it's lazier, but there will be times when it's a really complicated question when it'll be easier to think about it in terms of a north, south, east, west direction to get a handle on what's going on. Okay. Holly, what's example 2A asking me to find? I'll give you a hint. You want to read me the phrase after the word what? Just read it to me. That's okay. What? And then there's a word that starts with a C, a word that starts with an I, and a word that starts with an M. If you read those 3 words, you'll be correct. No. Under part A. There you. What are they asking me to find? Yeah. Oh, were you overcomplicating? No, you would never overcomplicate something. Okay. Okay. Sure, we believe you. Change in momentum, I abbreviate delta P. Okay. Now here's the question. Let's now, Holly, look and see what they gave me. Which version of impulse am I gonna, of change in momentum, am I gonna use here? What are they asking me to find in part B of the? I don't think I'm using force times time like the previous one because I don't know the force. In fact, what's that 2.5? Which one? What's that 18? I think I'm going to use the version of impulse that has the V final and V initial. Look up, folks. Don't write this down. Look up. Don't write this down. Look up. I'm going to think that, but what's changing anything, Hannah? I'm going to write this MV final minus MV initial. Write that down. Now, they didn't give me a direction here, so I'll do the old reliable Holly. I'll let positive be forward and negative be okay. What's the mass? Yep. What's V final? What's the mass? 350. What's V initial? 2.5. Here you probably need to use a calculator. What's the change in momentum? What's the impulse? What's the magnitude of the change in momentum in the impulse? Because they didn't give me the vector direction at all. 350 times 18 minus 350 times 2.5. Holly, did you get 5425? Oh, so sorry. Okay. Stop going for that. Slow down. I'm sure I'll talk slower. Do you have your torture done, movie? Okay. 5,425. I'll carry the extra sig figs because I have a feeling I'm going to use this for part B. Units, you could write Newton seconds. Since I went mass times velocity, my brain would probably write mass times velocity in my units, but I would take Newton seconds as well. They're interchangeable. Okay, Holly, keep going. What's B want me to find? Okay, the force. The force. Holly, F equals what? I have no problem. Don't write this down. Look up. If you go F equals MA, don't write that down. And then you say, hey, I need A. VF equals 18. VI equals 2.5. Oh, they told me time 60. Could you, don't write that down. Trust me. Okay. Could you find A from that? And then you could go, what? Yep. I'm fine if you do that. And one of my points I want to ramble on is sometimes students panic on impulse, and because they're not sure how to do it using the impulse equation, they quit. You've got the skills to handle this. But what I am going to try and do is solve this using the impulse equation. How am I going to do that? I'm going to say, you know what? Change in momentum, my answer from A, is also force times time. Evelyn, how would I get the F by itself? One line and we're there. It's a nice shortcut as opposed to F equals what, A equals question list. You'll get there just fine, and I'll give you full credit on a test if you do it that way. But what I would do is I would say, you know, the fact that I know the impulse, the answer is going to be 5425 divided by, what was time? 60. In fact, I can go answer button divided by 60. Force is 90.4 newtons. And if you went F equals what, M, and if you found it, you would have got the same answer. But one line versus 3 or 4. And that's going to be kind of my theme for today. Evelyn, you're going to hear me say over and over again, you can do this the long way, and I'll give you full credit. But for what it's worth, with a little bit of cleverness, the impulse equation, it's a nice shortcut. Example 3. Example 3. Nathan, what are they asking me to find in example 3? Okay, look up. Don't write this down, but look up. I have no problem, Nathan, if you go VF equals question mark from rest, VI equals 0, T equals 120. They gave me, you can probably, because they gave you a force and a mass, you can find the acceleration, F equals what, get the A by itself, and then you can go VF equals VI plus AT. Totally doable, and I'll give you full credit. But we can do this in fewer steps by using the impulse equation. What do they want me to find? Okay, I'm going to write something really, really dumb, but this we are going to write down, and then we won't write it down next time. I'm going to say to myself, you know what? This has to be true. Impulse has to equal impulse. Don't argue with me on that one. That has to be correct. Write it down this time. The next time we'll skip that step. We'll just do it in our head. What I'm really going to argue, Nathan, is this. Force times time is mv final minus m the initial. And in fact, as I got good, I would have jumped straight to that line right away. Pardon me? What? I don't even need to. What am I trying to find, Nathan? By the way, what's VI if we're starting from rest? So you're telling me this whole term would just vanish? Fine. Get in one line, get the VF by itself. This is where the impulse equation is kind of a nice shortcut. If you really get good at it, you'll find, a little bit of clever mixing and matching. I can save myself 3 or 4 lines of writing. It turns out yet another equation for VF is apparently force times time divided by m, which I'm not going to write down on my formula sheet. I can derive it. Did they give me a force in newtons, Nate? Yep. 2 point, whoop, what did I write a 3, Mr. Dueck? 2.3 times 10 to the 4th. Did they give me a time in seconds? Yep. Did they give me a mass in kilograms? Yep. By the way, even if VI wasn't 0, I bet you I still could have got the VF by itself. It just would have been a tiny bit trickier to rearrange the equation. But we're at this stage now. We can do it. And yeah, Davin, when you had your aha moment, it's a nice shortcut. That's all I'm saying. 2.3 scientific notation 4 times 120 divided by 2.6 scientific notation 4. Did you get 106.1, 106 meters per second? Is that all right, Maya? Example 4. Read it to yourself. And then Maya, what are they asking me to find in example 4? F equals what? I have no problem if you write that down. I have no problem if you then say, I need to find the acceleration. And if you find the acceleration. But here's what I'm going to say. As a really handy equation, impulse equals impulse. Get the F by itself. How will I move the T over? I'm going to do it in one line instead of 3. By the way, one word I haven't used in a long time, but we should underline, halt. What's VF as a number exactly? Yeah, I didn't say stopped. I said comes to a halt, but that means the same thing in English. In other words, this whole term is going to vanish. And in fact, I can start plugging in numbers. It's going to be 0 minus what was M. What was VI? 32. All over what was T? 1.6. I can do this in my head. Try this on your calculator. 1,600 divided by 1.6. I'm pretty sure it's going to be 1,000. It's going to be, yeah. Maya, what'd you get? Yeah, no. That's just my way of making sure you start typing. It's really my way of saying when you get the answer, call it out. Negative, sorry? Is it negative 3,200 or is it negative 32,000? I think it's negative 32,000 is what I'm getting in my head. I know. We all know. Oh, sorry. I mean, I know. Uh, Units, it's a force, newtons. What's the negative telling you? If the car is moving forwards, the force must be pushing. If the car is traveling north, the force must be pushing. If the car is traveling left, the force must be pushing. And that makes sense. Yeah, the braking force is in the opposite direction of motion. I'm actually okay with the negative. It doesn't creep me out. It says to me, I probably did this correct. Is that okay? At least most of us did it correct. Was there anything else? Nope. Okay. Example 5. Jackson, what does example 5 want me to find? Magnitude and direction of the ground acting on the rock if it comes to a stop in 0.350 seconds. Okay. Don't write this down, look up. My brain thinks this. Maybe I could, because they gave me a time, I'm thinking maybe I can use the impulse equation because force times time. So my brain said, okay, force times time equals mv final minus mv initial. And then I would say to myself, did they give me the mass? Did they give me the final velocity when it hits the ground? What? You telling me when you hit the ground, VF is 0? Okay, comes to a stop. Then did they give me the initial velocity right when we hit the ground? Okay. This, because I've done so many of these, is about going to be about the same amount of writing as if we went and just found A by going either of those are totally doable. But let's see if we can do this using impulse. So if you want to, you can write this down, the impulse equation divided by t. In fact, really what we just finished doing up here, except it's going to be a little more complicated. I totally agree that VF comes to a stop is 0. What I need is VI, which is V impact. How am I going to figure out V impact? What information haven't I used yet that this question gave me? That's the real question here. Sorry? Well, I think the time is going to be that time there, but I haven't. Okay, I think I'm going to now do a free fall question. I'm going to write a little line like this, and I'm going to say V impact equals. Now, V impact is going to be V final in free fall. That's going to be V initial when we start coming to a stop. So it's going to end up in there. Falls from the top of a building. What do you think VI is? I think this is kind of saying it got dropped. Yes? Oh, what's A if we're in free fall? Negative 9.8. Most of you memorized that. What's D? Don't say 40. Why would saying D is 40 be wrong? We have to realize it's a displacement, negative 40. Jackson, I'm going to go like this and say what I'm looking for on the right-hand side is a VF. It's going to become a VI on the left-hand side, but now I'm in my familiar notation. Lazy but organized. Looking for an equation that's got a VF, a VI, an A, and a D in it. There is one. R squared one. Right? VF squared equals 2AD. I didn't even bother writing the VI squared because 0. VF squared, how does one get rid of a squared? And the reason I also normally in a non-semester COVID year, you'd be writing a final exam at the end of the year. And so this would also be me cleverly reviewing free fall while we were doing this. And people, oh yeah, I remember how to do this now. If case you're going to start to notice in the next couple of units, I'll be sneaking in a lot of review. It was to get kids ready for a final. Won't be doing one this year. It's going to be the square root of 2 times negative 9.8 times negative 40. What do you get? 2 times negative 9.8 times negative 40, square root of that. This might work out evenly. I got 28, but you said negative. Did you? Why is it negative? You're correct. We have to overrule our calculator this time because our calculator always assumes we want the positive square root, which most of the time we do. Not this time. By the way, here's what else we've decided. Jackson, what direction is negative in my question now? Okay, so if I get a negative f, that will be, if I get a positive f, that will be, okay. Walk it to there. The impact force is going to be negative m 2.5, negative 28, divided by 0.350 seconds. Pardon me? I have no idea what the answer is. Time to go to my calculator. Right, by the way, technically it's 0 minus 2.5. I just didn't bother writing the 0, but V final you pointed out was 0. So MV final would be 0. So it's going to be brackets around the top, negative 2.5 times negative 28, close bracket, divided by 0.35. What'd you get, Jackson? Sorry? Positive or negative, first of all? Trust your calculator. What does it say? Positive, which means the force is which direction? Yeah, of course. If the Earth is bringing the rock to a stop, it must be applying a force up to bring the rock to a stop. So the fact that I can reason my way to what sign it should be, and I got the correct sign on my calculator, we probably did this correct. 200 even, that's a fluke that it works out so nice, but we'll take that. 200 newtons. Oh, what did it say in brackets next to the word force? So let's actually report a direction. So we're going to say the magnitude is 200 newtons. What did you say the direction was? Starts with the letter U. I would, if you didn't actually say that, if I asked for magnitude and direction, I would have knocked off like a half or so. Hey, give me the thing when I say magnitude and direction. By the way, you could have done this and let down be positive. You would have got a negative answer. What's negative down? Up. As long as you're consistent through your question, Cody, you'll be okay. I would recommend do it the way most of us will, so your work looks like our work, but whatever. A couple more, we're going to hit pause. A ball moving east hits a wall. The wall exerts a force of that to the west for that many seconds. Find the final velocity, magnitude, and direction of the ball. Okay. Davin, what's this want me to find? I would have, don't write this down, no problem if you went VF equals question mark. If you then said, oh, they gave me a VI. Oh, they gave me a time. I can find A by going F over. I would have no problem doing that. But I'm noticing a couple of things. First of all, do you see a word that starts with the letter E and is a direction? Davin, my friend. Do you see a word that starts with letter E and is also a direction? Do you see a word that starts with letter W and is also a direction? Specifically, folks, do you see there's two different directions, opposite directions? We're going to have to let one way be positive and one way be, Davin? What do you want to let be positive, east or west? Pick. I'm going to be lazy but organized. So the very first thing I'm going to do before I even start is I'm going to say, well, that's positive. That's positive. Ooh, that's negative. That's negative. Why didn't I put a negative in front of time? Time's a scalar. Has no direction, much like your time's a scalar. Let's see if we can use that version of the impulse equation, the one that says force times time equals m v final minus m v initial. Impulse equals impulse. Davin, what are we trying to find? Get the VF by itself. What side is the VF on? Left or right? So the left side's going to drop down like a domino. Okay, I'll do that first. Yeah, we got to walk it through it for everybody. Okay, then what would you do? Add the VI? I disagree. Plus what to the other side? I think you misspoke. Thank you. We're going to go plus the MVI over because it's got a minus next to it. And that would leave us with MVF. How would you move the M over? Here is yet another equation for V final. Do I need to add it to my formula sheet? I'm hoping you're comfortable deriving it because if you're trying to add every one of these, your formula sheet's going to be pretty cluttered. Okay. VF equals, I think we can start to plug in numbers now, Lean. Good. Got your head up. Davin, what's F? No, it's not. What? Negative. And that's, by the way, an easy mistake to make. If this was multiple choice, I would have a positive 350 answer that I'd crunched for you to pick from as well. In fact, I'd probably make it A just to really tempt you. So I agree with you. Negative 350 because it's west. T. Keep going, Davin. T. Good. And then there's a plus sign. M. Now it's going to be 4.2. And VI, positive 4.65. I won't write the positive because by default it is. All over. And you can see two lines and we're there. And again, if you're not comfortable with this or you're just a little shaky, Hannah, I have no problem if you do it the longer way. You'll get full credit. It's about 5 lines in case you're wondering. Go ahead. But the impulse equation, it's really a nice shortcut. Is this a fraction? Yeah. Is there more than one thing on the top? Yeah, all of you should try typing this in. I got to put brackets around the top. Negative 350 times 0.075 plus 4.2 times 4.65. Close off the top divided by 4.2. Davin, what'd you get? Sorry? What's the negative telling us? Direction. Okay. So VF equals negative 1.6 equals 1.6 meters per second at west. If we use our imagination, west is that way, east is that way. I guess the ball came in east. The wall applied enough of a force not just to stop the ball, but to get it to bounce off and head off in the other direction. Okay, yeah, I've thrown a ball against a wall before. That happens all the time, but there's the physics of it. Is that a question? Stretch? Okay. A rifle accelerates 12 grams. Nice try, Dueck. Don't do physics with grams. How do I convert grams to kilograms? It's divide by 1,000. So 12 divided by 1,000. Double check me, but I think it's going to be 0.012 kilograms, right? From rest to 250 meters per second, the rifle barrel is about 0.85 meters long. A says find the impulse acting on the bullet. Impulse is just change in momentum. Hmm. Version of the impulse equation might I try here? Yeah. I see a final and initial velocity and a mass. Yeah, I would jump to this one. mv final minus mv initial. In fact, you know what? Since it's from rest, I could even just do that. I could have just said, I think it's going to be mv final. It's going to be 0.012 times 250. And I get, oh, that's nice. 3 even units. Well, I went mass times velocity, so kilogram meters per second. Yeah. It didn't ask for a direction, so I got a pause. Oh, in the direction that the gun is pointing, I guess, if we're going to be obvious here, whatever that happens to be. Okay. Dina Goodyon? What's B asking me to find, Dina? Find the, I'm looking, force. Don't write this down, look up. My first thought, what did we just find? The impulse, change in momentum. My first thought was this. Well, why don't I go like that? And I just thought that in my head. Did they give me time? You know what? Here, what else did they give me that I haven't used yet? I think here, I'm going to go write this down, F equals ma. So it's not always faster to use the impulse equation. Sometimes F equals what? Ma is our method of choice. Because now I would say, okay, A equals question mark. Mara, what was VI? Maya, what was VI? Sorry. What was VF? What was D? And I think it's positive because it's moving forwards through the barrel. I can find A. I'm looking for an equation. Maya has a VI, blah, blah, blah. Get the A by itself, please. I know. I know. Give me the other one and then get the A by itself. It's because I was expecting you to get it right the first time. I'll never make that mistake again. No. Right? Much like a Star Wars sequel, just lower my expectations. So VF squared. Or I think now more recently, much like an Indiana Jones sequel, just lower your expectations. VI is 0? Well, that's a bonus. So it's going to be 250 squared all over 2 times 0.85. It's going to be 250 squared all over in brackets 2 times 0.85. I have more than one thing on the bottom. Brackets are on the bottom. Should a bullet have a big acceleration or a small acceleration? I'd be worried if I got a small answer because, Mr. Dueck tries to make answers ballpark accurate. So, okay, yeah, that seems about right. 36, I'm not going to write all of this. I'm going to store it on my calculator. I'm going to write 36,800. We're not done yet. We just found A. And now what we're going to do is walk it to there, right? So yeah, that's whoever asked that. That was a great question. Was that lean? Great question. So now we're going to go F equals 0.012 times my answer button. And I get an average force of 441 newtons. Is that right? Now that you knew the force and the impulse, I could also ask you to find the time, get the t by itself. Yeah. I was going to pause, but we might be able to get through this whole, I mean, there's, you know what I'll do? I'll give you a head start on the homework and then I'll finish the lesson on Monday, I think, because there is going to be a lot of homework. So for now, I'm going to hit pause. I'm going to show you a short little video, I think. No, I'll show the video next class. You can try number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This was me just sitting down and asking, what's all the various ways, Hannah, that I can mix and match impulse and mass times V final minus mass times V initial and force times time and M delta V. What all can we pull out of here? Okay. You can try 1 to 11. 12 is good. 13 is good. 14 is good. 15 is good. And I'll let you try 16. We'll pause here. I'm going to be assigning more, but I'll do that once we finished off the lesson as well. Okay?